Okay, let's proceed on insulation non-destructive testing. Okay, list of non-destructive testing. Okay, so in non-destructive testing, there's a loss in dielectric. We can measure this one. Resistivity, dielectric constant, and loss factor, sharing bridge, latch capacitance, testing, transformer ratio, arm bridge, partial discharge, bridge circuit, current, surge generator. Okay, in dielectric, there are three types of loss. Okay, as for
Doctor, can
yeah,
you show the slide?
oh, I didn't
I
start.
can't see.
Oh, sorry. Okay, for loss in dielectric, there are three components: conduction loss, okay, conduction loss, okay, noted as PC, okay, due to ionic or electronic conduction, and dielectric conductivity, sigma, and polarization loss during deformation, and ionization loss due to partial discharge or internal discharge, or internal or maybe external out of the uh, dielectric. Okay. For polarization loss is during when we apply voltage to the dielectric. Okay. Initially, it is not aligned. The molecule is not aligned. Negative, negative, positive, 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 negative. Like this. Yes. Imagine this is the electrode HB and ground. When the switch is off, it's not aligned. When I turn it on, so all of these will align, as I mentioned in our previous class, align to the direction of electric field. Okay, so this one will rotate. For example, this one HB is positive, positive, and this one ground will become negative. So it will attract positive, will attract this negative charge inside the molecules, rotate. So it will rotate. Initially it's like this, so it will rotate. For example, this is negative, this positive, rotate. Everything will align according to the electric field. Okay, so that kind of uh, energy loss. Okay, loss factor measurement in AC test. Dissipation factor tan delta is ratio of real current component I omega to the reactive power component. Okay, so real power component is the real current that flows through a conductor. Okay, it can be current maybe you can measure it outside of the capacitor, and the other one uh, the reactive component is this displacement current due to the alignment of the dielectric materials. So in phasor we have a real component here and the reactive component here. So the tan between this one, okay, this is I omega, which is the reactive components, and the real components here, IR. So tangent is I omega over IR. Okay, so we can check this one to determine the aging of the insulation. Meaning that if there is a lot of current here, this current tangent will be higher, so the insulation must be uh, replaced. Okay, next one is partial discharge. Okay, partial discharge is not a complete discharge. You can imagine like this electrode here, we have HV electrode here and ground electrode here. And partial discharge is a halfway discharge, okay, a spark discharge. It doesn't connect to the ground electrode. No. Okay, this is partial discharge. Okay, like creeping discharge here. If we have solid, this is solid, solid insulator. The creeping discharge, the creeping spark here, or maybe a barrier discharge like this one. And again, this is also solid. We have high voltage here, and this is air. The discharge can also start at the dielectric, outside the dielectric towards the ground electrode like this. If this HB electrode is properly isolated or covered with insulator. Okay, and also discharge can also happen in a solid void inside the solid. Void is air pocket inside the solid. Okay, or maybe like this one due to the treeing process. Okay, this is tree inside solid insulator, and it will induce discharge as well inside the void is present. Okay, so of course you can hear it. Okay, you can hear the partial discharge sound, like hissing sound like that. Okay, if you go near to a substation, you can hear that sound. That is the sound of partial discharge. And because it release sound, we can also measure it through acoustically through sound device. Okay, simply we can say it through microphone. Okay, and as it also release the electromagnetic wave, we can also measure it by using antenna with a proper data analysis after that to remove noise. Okay, so not much we can discuss in this chapter. You can find more in the textbook. Okay,